Greetings everybody, and welcome to Euclid's proposition number 32. In this proposition we want to show that the sum of the angles of a triangle will be a straight angle, that is 180 degrees. Now let's take a look and see why this is going to be true. Let's suppose that we're just given a triangle ABC. What we want to do is to extend the base of that triangle into a ray. Now we are able to do that by postulate number 2, which says that if we have a finite line segment, we are always able to extend that to an infinite line. Now what we want to do is to consider this side AB. What we want to do is to construct a line that's going to be parallel to AB that passes through C. Now proposition 31 tells us how we can do that with compass and straight edge. And if you want to go back and review that, it's not a bad thing to do at this point. But we can take a shortcut, and GeoGebra provides a tool, a parallel line tool, for which we can just pick the line that we want and then pick the point that we want, and GeoGebra will draw the parallel line. And so if we do that, we have, voila, a line that's going to be parallel to our line AB. Now, just for reference sake, let's pick a point on that line so that we can kind of refer to different angles. Now let's focus in on some of these angles. Well, let's go ahead and extend so that it does look like we have two parallel lines, AB and CE. Now, just to kind of keep the clutter down a little bit, let's turn off our line segment BC for just a second. Now, because these lines are parallel, what proposition 29 tells us is that the interior angles are going to be congruent. And so, in particular, that means that our angle BAC is going to be congruent to our angle ECA. Now we want to consider the other side of our triangle as being the transversal as well. So let's turn our other side on. So we have side BC, and now let's remove side AC and those two angles as being clutter. Well, again, by proposition 29, what we know is that the interior angles on the same side of the transversal are going to be supplementary. That is, they're going to add up to 180 degrees or give us a straight line segment. And so what we then have is that our angle, if we turn on one of them, so our angle ABC together with our angle ECB is going to add up to 180 degrees. And sure enough, if we look at the values in GeoGebra, we see that 126.1804 plus 53.8196 does give us 180 degrees. But now, bringing back our triangle, if we turn back on our line segment, AC, and we turn back on our angles, our two congruent angles, what we find is that our angle ECB is really equal to our angle ECA plus our angle ACB. And so what that really gives us then is, by our common notion number 1, is that the sum of our angle ABC plus our angle ACB plus our angle ACE gives us a straight angle, or 180 degrees, as was to be proven. I hope you guys have enjoyed this video, and I will see you guys in the next one. Take care.